请听我说，请感受着我，所有你迷惘的我都懂，请让我在耳边唱歌，关于你梦中的理想国。空间时间交织，连成线融在身边，不知又不觉，眼看不见。难道这真的没有存在过来过？乌兰云眼泪声和闪电，一朵昙花盛开在夜间。到底有点什么都不见，名为真相的幻影毫无意义，所有人质都隔着一层多真实。若能感知胸口的呼吸，就该坚信脚下的位置都在重重的梦里，谁比谁清晰，他们不懂。停留是旅行，我要的只是我爱的人站在这里，我就守护这片土地。人来人往，皆是虚妄，看清楚你真实的形状。树影流星，万物的声音，飞鸟掠过天空，很平静。这些回应纵身不是无缥缈的，只是幻日天光云影握紧的手心，诺言相约，心里的心灵都是假象，却让人爱着。名为真相的幻影本无意义，人却用心倾注了血肉和热情，心动一下，万物就像人爱与否本无关。哇 Hello Seymour, hello Joel. And I'm early. Yes, I am early. Mainly because I sat on the computer like half hour ago and I had nothing else to do. So I decided to maybe start it early and let's maybe try to finish this subset of problems. Hello, her Pat. Also, thank you for always scheduling the events in the Discord server, Joel. I appreciate it. Okay, anyways, as you can see here, the patterns for 2 pointers, we only have 3 more left. So the goal today is try to finish these 3. And if I manage to get them done early, maybe I'll schedule a master duel later, because I have enough dailies for me to finish. Anyways, let's start. Problem challenge 1. Quadruple sum to target. Given an array of unsorted numbers and a target number, find all the unique quadruples in it, whose sum is equal to the target sum. So a 4, 1, 2, -1, 1, -3, and target is 1. If the quadruples add up to the target. Joao is that happy? If Joao is happy, I'm happy. Unique quadruplets. Quadruplets. So we need 4. Each album contains 4 items in there. Okay, that indeed is a challenge. I think the easiest way for us to start is sort the number first. So array equal to array dot sort. And we are putting A, B, where A minus B. So we're sorting from the smallest number to the biggest number. And then console log array. So output is -3, -1, 1, 1, 2, 4. -3, -1, 1, 1, 2, 4. So I think we have done something similar in the previous problem, but it was looking for threes and triplets within the array. But this one we are looking for quadruplets. Let's say we have I and put a left pointer here and right pointer here. We're gonna add these 3 numbers together. What's the target is 1. Target is 1. So if we add these numbers together and if the number is less than the target, then we move left. And more left, and then plus the left number. In this case, if plus a number is equal to the target, then we find the first pair. After we find the first pair, I want to say increment I, but we know the result. We know the result, so use this. So instead of increment I, we have L start at the new L. So now it's I equal to -3, 1, and 4. And this combined is actually equal to targets. If it's equal to target, so if n is equal or greater than targets, then we shift right number. And then we calculate this. Then we shift right number. So now right number is 3, 1, 2, which is less than. So now we shift the left number. So now it's 3, 1, 1, 2, which is equal to the targets. And we found another pair. So now left and right is here. If left is, we need to end this loop somehow. We need to end this loop. So the loop condition should be if right minus left is greater than or equal to, no, not 0, 1. Then we end the inner loop and increment I, and then repeat this process. So let's try that. So for let I equal to 0, I less than array.length minus 1, I plus. I think this we don't need minus 1, we need minus 3 here because we need 4 numbers to finish this. So by the time we hit the last third, the last third number, we know we cannot make a quadruple anymore. Right, so and then we're gonna make let's left equal to I plus 1 and right is equal to array.length minus 1. If right minus left is greater than or equal to 1. Actually not, with while is less than or equal to 1. Actually less than 1. Why is important? Because this is a quadruplet, not triplet. If it's triplet, then we can do right less than left. So what we want to do right now is we're gonna add let's initialize a value, and sum is equal to number dot maximum safe value. Sum is equal to array I arrays I plus array left plus array right. If sum is less than the targets, we need a new pointer for this. Let's call it move. Move is equal to 0. Actually, that doesn't. Wouldn't it be better to stop when right is equal to left? If we do right equal to left, that means we only have a triplet. So if you want a quadruplet, if right is like, for example, if right and left meets, well, for sure we cannot make a triplet. But before they meeting, for example, right is here and left is here and I is here, you cannot make a quadruplet anymore because there is no number in between left and right. So that's why you need to do a less than 1. That's why I'm doing less than 1. So if the question is asking for triplets, then you are correct, but the question is not. So lastly, we can plus, we do a condition here, move is equal to 0. If it's equal to 0, then we return 0. Otherwise, we return array.move. So initially, like the move will always return 0 in the initial trigger of this while loop. So if sum is less than targets, we want move to be equal to array left. Actually, we want move to be left plus us. Left plus 1. Just making sure that it's not incrementing left. Else if the sum is equal, actually, if it's equal, then we found a bear. So we don't know move here. Okay, so I can make this check even more complicated by checking whether the move has been updated or not, and then we check if it's equal or not. But I think we can simplify this a little bit. So for let's B, let A equal to I plus 1. A is less than array dot length minus 2. A plus plus. But the problem here is I think this is a n square. So we can break this down into like into a so let's forget this is an I. We can break this question down into looking for triplets. So the target is actually just I minus this target. So we can set a new target here. It's called tar, equal to targets minus array I. Right? And then left is equal to A plus 1. And right is equal to array dot length minus 1. So while left is less than right, if array A plus sum is equal to num maximum safe value. We can update the sum into array A plus array left plus array right. And what we want here is if the sum is equal to the new tar that we set, then we found a pair. So we're gonna do quadruplets dot push array I, array A, array left, and array right. Else, if sum is less than the target. If sum is less than target, then we know if sum is less than target, we know the leftmost number needs to increase. So we do left plus plus. Else it'll be sun is greater than target, then we decrement right side. Right, so and then submit this. Runtime error. For I equal to 0 and less than array. If array dot length is less than 4, if less than 4, return nothing. Return quadruplets. At this point, it's just empty. But I don't think this has anything to do with this. Okay, so let's see. For let I equal to 0, I less than array minus length minus 3 I plus plus. For let I equal to I a equal to I plus 1, a less than array dot length minus 2 a plus plus. The new target is target minus array I, which is the first value, and left is equal to a plus 1. And right is equal to array dot length minus 1. And sum is number maximum save value, while left is less than right. Sum is equal to a plus left right. If sum is equal to the new target that we set here, then we found a quadruplets. If sum is less than the target, we do left plus plus. If sum is greater than target, we do right minus minus. It sounds about right. Wait, is 10 making up stories about me? Hello. What made me start streaming coding is that my real job is a software engineer, and I have been laid off for a little time, and so for some time I've been doing streaming full time, and then I figure I might as well just start doing coding. Macedon? Maybe I may play Macedon later. Line 1, 30 kills. Line 1. Run line 1. What do you mean? Line 1 is just the solution, class solution. True, false. This is fine. So something wrong with this. Array dot length minus 3. Array dot length minus 2. A equal to I plus 1. So this part is fine. And this part is fine.
And this part is also fine. So something happened here. While. Good morning, and my name is not Demon. Oops, yes. Oh, even the noob here. Okay, let's see. How did we end up with the even loop? While left is less than right. Left is here, right here. Some is here. Oh, it's a and oh, it's answering this is equal to this, and now. Oh, I see. If we found a pair, what do we do? If we found a triplets. If we found a triplet break it out. I don't think break it out is gonna work. Actually, you know what? If we found one breakout. Okay, then. Woo! Okay, let's start it next. Wrong. Damn. The input is 000, output is 000000000000000, which is technically true because this 0 and then this 0 and then this 0. Wait. Okay. That's weird. How are you supposed to count in 0 there? Unique. Find all unique quadruplets in which sun is equal to target number. Okay, so they're saying we cannot have this value equal. So in this case, well, no, it can be equal. So, because it's all 000. It can be equal, but only once. So I need to make sure that if quadruplets dot contain has array has AS array has F I don't think this is gonna be contained. Bye. Okay. Array fine. We can do an array fine, but this is gonna increase the computations. Fine. So we only push if it does not contain array of this already. So now in this case it should return just one. So if I use this as case, submit object array is not a function. This is not a function. How do you make sure the find element? Oh, because this needs to be an element. So A, B, C, D. That's equal to A, B, C, D. Is that the same? A, B, C, D. This sounds wrong. Run. Well, this sounds wrong, but it's working. The break should be inside. No, the break shouldn't be inside. We want the break to trigger regardless if it's if happen or not. Array unique subarrays. They use native filter method. Value index array. Return array index of value is equal to the index. That sounds That sounds wrong. So if I want to do unique, I can. So first we keep pushing these values, and then lastly we just filter for unique. It sounds wrong, but for duplicate of future value index, what's a array, and if array has index of this value, which is equal to the I. So if array index of the value, actually you know what? You know what? I don't need to do this. So quadruplets dot index of this. If the return is if return is some number, right? Returns the index. Returns -1 if not present. So if it's equal to -1, then we push. So submit this. Wait, what the heck? Why is it 0, 0? If quadruplet index of this value is not found, then we push. So it'll be index of 0, 0, 0, 0. After the first one, you should find the 0, 0, 0. The 0, 0, 0, 0, 0, 0. And then we console log again the index. -1, -1, -1. Wait, what? Why is it -1? Index of this value. Index of this value don't exist. Return the index of first occurrence of a value in an array, or -1 if it's not present. Search element, any array. I'm searching for 0, 0, 0, and it says 0, 0, 0 does not exist. Then that's not what I want. index of this. So it's only searching for elements, it's not searching for array. Search element from index. Index of array. Okay, so this one is looking for index of this array. It's not. That's because you're searching for a different object than index of using strict quality comparison like this, and this is not equal to this returns false. Oh, you need to search manually. Here's an example using index of. Damn. So if you're doing index of array inside array, the array inside array is doing a equal 3 triple equal operator, and this triple equal operator will show false even if the elements within that index is correct. Then this is making it too complicated. Okay, I feel whatever I'm doing is kind of little bit overkill. Wait, hold on. What if I... Nah, it's still gonna compare index. Oh, this is making it into a hash map. Okay, I guess hash map works. So if we do a hash map, constant hash is equal to a new hash map, and then if we find one of these, then we push it to hash map. Hash of this value is equal to 1. So if hash of this value does not exist, then we push. Okay, not correct. Yay! Commits? That's wrong. And what's wrong? We're missing one number here. So -2, -2, -2, -2. So both of these are -2. That means what we have here are increments. If this breaks out, then for sure I is gonna increment. What we want here is, because this this is a increment, right? So this is I, this is A. So if they found one pair, right now what we are doing is increment the 8, but we don't want to increment 8 here. Let's see. What if I increment both? Oh, how they can create new one? Okay, new one. Okay. So in this case, it's -2, -2, -1, 0, 1, 1, 2, 2. -2, -2. So this is I, this is A, 0, 2, 0, 2, and then left is here, right is here. Oh, I think I'm overthinking. So, we know, right? The next iteration, this cannot be right because this does not satisfy. This does not satisfy the condition because this will be the same as previous, so it's a duplicate. So, before I was thinking, I need to compare left and right for the next value, and then whichever is the smallest, and then we move that to the smallest number, but and keep if they're the same because that's easier to find a quadruplet, but that doesn't work because the quadruplet has to be unique. So if they're the same, because these two values are the same, so if you move the year, this is not valid anymore because we already have a same subset of array with the same number. So we don't need to do overthinking this part. So instead of breaking out, I can do left plus plus and then right minus minus. And run again. Submit. Yay! Yes! Okay. So basically, do not overthink. Okay, let's see what they have for a solution. This problem follows a two-pointer pattern and shares similarity to triplet sum to 0. Yeah, that's what I said before. You don't understand? It's easy. So, take this example, right? We have two loops here. We initialize I as the first number, initialize A as the second number, and then we put a left and right here. And then we combine these four numbers for them to equal the target. So I updated the target to be to be I minus target. So basically A is looking for a target. But to keep it simple, we basically have this 4 number looking for to be similar to the target. And if it's less than the target, then we know that because this is sorted, we know the smallest value here has to be increased. So we increase right. But if it's greater than target, we know the bigger number has to be smaller. So we decrement right side. I don't do that. So until we find a pair that's we continue this process until we find a pair that's equal to the target that we want. And then we put out the target. And we continue move these 2 pointers until like right left is reversed. Then we increment A. Right? And then we do this process again. And then we increment I, and then increment A, increment I, until we find all the pairs. And we are looking for unique numbers. So we use a hash map. And which hash map we use the key? We use the key of I, A, left, and right as a key. So if these 3 numbers the same, then the key is the same. That means we already found a value of this same key in the hash map. So if we find the same key in the hash map, then we basically not push to the final output. So in the end, the final output will be unique quadruplets of 4. That's equal to the sum. So it's important is another navigate points to some we calculate, then we generate the quadruplet in a particular order. So sorting. First sort that thing, which is what I did. A list of named quadruplets is created to store all triplets found. The algorithm then loops through the array, stopping when there's less than 4 elements remaining. So less than 4 elements remaining. So in this case, this is why I did a -3. So -3 is like there will be. We know that there will be at least 4 elements left in the array. If the current element is same as previous one, it's not the first. We skip this turn over duplicates. Same as previous one. Oh, okay. So they did a skip here, but I didn't have skip. But we have a duplicate check. So that's basically the same method. And nested loop is either initialized from the next index of other loop. This also ensures the current element isn't the same as previous one. So this is where the A comes from. The search pair function is called within the array. Target value indicates the first element and quadruplet list. This function will find pairs in the array, which is left and right. So the first one is the second one plus 1, which is in our case was A plus 1. To the and then to the end, which then is the A array first and A second. I use I and A, so but it's the same method. Then search 2 pointers left right. And then you find that okay inside this loop the sum of element the current 4 indexes is calculated. Then we target basically. Okay, so I came up with the same method. Let's see what they have here. IJ, they call it IJ, I call it IA. Left right, and then check whether they're equal to the targets. If it's equal to the target, then we move left here, move right here. That's what I did. Until these two meet or when they're greater than, then we increment J. J is here. and then we start checking left, right. And then if they're not, if the sum is greater than target, so the biggest number is the right side. If it's greater than, then we decrement the greatest number. So move the right side to here, which is here. And then lastly, if it doesn't found, then we increment j, and then do the compare again. And then and then because j now is less than j require the array to have at least more than 2 elements left. So in this case, after the j is incremented, there will be only 1 element left, which cannot satisfy the condition of quadruplets. So now we move on to the next. We move on to the next by incrementing I, and then initializing j again to be I plus 1. Yeah, so this is exactly what I did. Cool. Problem challenge 2. Comparing strings containing backspace. Given two strings containing backspaces identified by the character number, sharp. Check if the two strings are equal. Given two strings containing backspace. Check if two strings are equal. Input is x, y, sharp, z, x, z, z, sharp. After applying the backspace, the string becomes x. Cx. Oh. So this means we remove the y from here, so this becomes xz. So sharp is it means we are removing the element before. Okay, this is kinda easy. We can do a reverse order. So instead of starting from here, we're starting from the bottom. Because if we find a sharp, that means we're gonna skip the next value. So let's left is equal to string 1 dot length. That is 1. Then right is equal to string 2 dot length minus 1. While left is not equal to, well, left is greater than 0 or right is greater than 0. if okay, so let's take this example. Let me make a new one. XY sharp Z, and then Z sharp. So we start from the bottom here. But if you find a sharp, then we update the index to be index -1, index -2, because we're skimming this value, and then we compare these two. If they're the same, then we index ++, and then we find the next value. If we find a sharp, then we skip 2. Alright, so in this case, if string 1 left is equal to short, then we do left -2. And if string 2.right is equal to sharp, then we do right -2. So let's make a stopper here. Continue equal to false. Now this will reserve value. So com equal to false. Is equal to true. Equal to true. If com, then we set com false, and then continue. So continue this loop. If string 1.left is not equal to string 2.right, then these two values are not the same. So what we want to do? So we just return true or false. So we return false. So this should, okay, there's a special case here because after we find this, eventually one of them is not gonna be the same, but the first one should be correct. If this is right, then return false. Otherwise, we do left minus minus and right minus minus. So the first one should be correct, but we're gonna hit a we're going to hit a special case here. SP sharp. So this one, the first one hits the sharp. Alright, so con is true. And then this, oh, okay. I see what's going on. I thought sharp means you're skipping the next value, but you can actually sharp and skip 2. Oh. So I need something to track the shop. We can create an array of 0, 1 is equal to, actually no. Sharp. Let's call it sharp tracker, and we set it to 0 and 0. Alright, so if this is equal to sharp, then we sharp 1 plus plus. If this is equal to sharp, then sharp 0 plus plus. And then we keep doing this until we found the shops. So if sharp 0 or sharp. 1 contains stuff that's not contains a value that's not 0. If sharp 0, then actually no. This should be while sharp is 0. While sharp there's sharp in the left side. We do left minus minus. And then sharp 0 minus minus. While they are sharp on the right side, we do right minus minus and then sharp right minus minus until we find all of them. Ramp. Infinite loop. Also, Mac, can you stop spamming? Can you stop spamming nonsense and then deleting them afterward? 新年快乐，新年快乐。So the first one, we are looking for all the sharps. Oh, it's infinite loop because if you find a sharp, okay, we need to do left minus minus and then right minus minus. Okay, that's fine. Output is false, but it's true. Let's simplify this. We're gonna function by sharp. We're looking for index. We're looking for string and index. String and index. The index should be referenced by. Wait. So is JavaScript passed by reference the whole time? JavaScript passed by reference. Pass variable. Is that Google Flow still a thing? I mean, they have a lot of old codes that people asked. So it's a thing because search engine is a thing, and they index a lot of old questions that a lot of people asked over and over again. Legacy responses here, basically. You can also at this point you can also ask ChatGPT or stuff like that. It's not passed by reference language, but instead it's passed by value. Or it's variable pass. In JavaScript, an object is passed as argument. So there's no pass by reference in JavaScript. So all the function params are passed by value instead of reference. Okay. I was trying to shorten this, but I guess that doesn't work. Because if I shorten this and then I just pass the string and index, and then I decrement the index within this function, so I don't need to call this twice. But since we cannot pass by reference, I just have to call this. Okay. So for this question, we find a sharp. We do left minus minus. And then the second one, we also find a sharp. We do right minus minus. And because the con is true, then we reset the con and continue this loop. And then on the next iteration, string 1 left, we also find a sharp. We do sharp plus plus. And then we move left. Right? So, and then con is now true. And because this one doesn't have a sharp here, so this one is skipped. Now con is still true. We continue this loop. Now both cases are no longer sharp, so we enter this bar. We enter this bar because sharp is now at 2 for left value. Sharp is now at 2, right? So we find one sharp, we do a left minus. Actually, you know what? Left minus minus. Because this one we found a sharp. We do math notes here. And now because sharp exists, we minus minus again. And decrement sharp. And then while this is now sharp is at 1. So we do left minus minus again. Now left is 0. Sharp is now also 0. And then for the next one, we find sharp, we do a right minus minus. Oh, we do a right minus minus here. And now the right is pointing at the next sharp. But we already passed these calculations. So now this is not equal because index of nothing is not equal to sharp. So this returns false. Oh, I see, okay. So ideally after we finish computing the sharp, we want to compute this again. Let's create a new layer. A B sharp sharp, A B sharp sharp, and then C sharp, D sharp. We initialize left pointer here, right pointer here. Array object path for reference variable, yeah. And so at this point, I might just start using ChatGPT. I'm just not used to do that. So we have a sharp counter, right? For left and right. If we find a sharp, we increment the sharp counter. And then we move on to the next. If we found a sharp, we increment this sharp counter. We move on to the next. And if the next number is not a sharp, and we have a sharp counter, we decrement this sharp counter, and then move on to next. And this one, since it is sharp, we move on to the next. And we increase this. Yeah, this is basically what I'm doing. But what I'm missing here right now is after we decrement this value, if the next one is again a sharp, we are not recalculating this bar. So we need to compute until all the sharp counters are gone. Oh, okay. So instead of calculating this, what if I just continue? This was still false. So in this case, we did a right mass minus, a sharp mass minus, and then we continue this loop. And if after we continue, the first one did not find a sharp, so this pause skip, but this one finds a sharp. So count means continue. We continue again. The next continue, both of them don't find a sharp, so we go to the next one. And this has no sharp anymore. Oh, this exits the loop. So this has no sharp anymore, but this has a sharp. So we do right minus minus again, and sharp minus minus, and continue. Technically, what this, both of them don't continue anymore because both of them will be 0 at this point. What do I need to do in this challenge? I need to find the string 1 and the string 2 is the same, but within the string, if you see a sharp in the string, you take out what the previous number is. But the sharp could be continuous sharp, so means if you see 2 sharps, you're taking out 2 previous number. Oh, you know what? I see why it's not working. These are string. I'm looking at. Arrays here. So string 1 is equal to string 1 dot let's convert it to an array. JS string to array. Hello, it's string with array of strings. That's fine, that's what I want. So I just do a split. String 2 is equal to string 2 dot split. Run. Oh. Yeah, I don't have a good idea anymore. Let's look at solution. To compare a given string, first we need to apply backspace. An effective way to do this is be from the end of the both string. That's what I'm doing. We can have separate pointers pointing to last element of the given string. We can start comparing the character pointed out by both of the pointers, see if the string are equal. If at any stage the string points out by any of the pointer is backspace, we will skip and apply the backspace until we have a valid character available for comparison. So in the compare function, 2 pointers are initialized, index 1, index 2. In my case, it's left and right. The last index of string and string 2 respectively. A while loop stating which will continue until both pointers are less than 0. Less than 0. Both are less than 0. While both are greater than 0. Greater than or equal to 0. Yep. Inside this loop, for each string, get next valid character index function is called with the current pointer If this function returns the index of next valid character, traverse from the back to forth fronts by taking into account backspace's character. I1 and I2 point to the index of next valid. If both are less than 0, it means the end of the string has been reached and the string is considered equal. If only one is less than 0, it means the end of the string has been reached but not the other, so the strings are not equal. If the character index of I1 and I2 are not the same, the strings are not equal. If no disable condition met, the loop continues until the next valid. The get next valid index function accepts a string index and uses backspace to count to keep how many backspaces has been encountered. Backspace count. So we have a counter here. It then loops through the string backwards from the previous until it counts a valid character and reaches the beginning of the string. If backspaces are found, the backspace count is incremented. If a non-backspace character is found and there's any counted backspace, one backspace is subtracted from the count to simulate the removal, and loop continues. If a non-backspace character is found and there's no backspace left, the loop breaks and the index of the valid character is returned. Oh, okay. Function get ballots. Get ballots. We're looking for we're looking for a next valid value. So we're taking a string and we also should be taking an index. Okay, so we're taking a string. We're taking a string and the current index and return the next index. String and current index. While staying at the current index is equal to sharp, we increment the sharp counter. Which is sharp. Oh, if we don't care about, we don't need to keep track of both. We can keep track of one. Sharp is equal to 0. Then sharp plus plus. And then index minus minus. While sharp Actually, you know what? I should look myself. Shell plus plus. And then we want to get the next values. So string and index -1. If we find a shop, then we increase the shop, and then we find the next shop. Wait, but this returns an index. Index 1, index 2. Backspace count is 1. Backspace count is 1. We go to next, backspace count is 2. We go to next. Okay, for each backspace count, we move left. And then this also move left. Because this is a sharp, so we increment backspace count. Because this is not sharp, we decrement backspace count. Well, index is greater than or equal to 0, greater than or equal to 0. This bar is the same. Or index 1 is equal to the value at the current tab. In my case, I converted string into array, so I just, instead of doing this, I just take the index of the array. So this is fine. If both of them are less than 0, then it's the end of it. Okay. If one of them is equal to 0, then we reach the end and one still has a value. If they're not the same, then we return that. Okay, that's fine. Oh, okay, this can next index value. Index 1. So we're passing a string index. Let the counter is equal to 0 while index is greater than 0. If the string is a sharp, then increase sharp counter. Else, if the sharp counter is greater than 0, we minus the back counter. while index is greater than 0. Else break. If it's equal, if it's equal. If it's equal to sharp, then we increase back counter. If it's greater than 0, we decrement back counter. If it's equal or less than 0, then we break. We found the next number. And then just index minus 1. Oh, okay. Let's count equal to 0 while index is greater than or 0. Greater than or equal to 0. If count, if string by index is equal to a sharp, then we increment counts. Else if counts if we find a count, then we reduce the count, because we always decrement the index. Else break. So if we find a count, we decrement count. If it's not sharp and there's no count left, then we return. Then we return the index. So while left is equal to greater than, right is greater than. Let index 1 is equal to string is equal to get values. Then we pass in string 1 and then index. Index is left here. And then index 2 is equal to get values. We pass in string 2 and then right side. And if so, I1 will be the next valid value after we are counting the sharp. I1 is the next value after we are counting sharp, and I2 is next value. So if I1, actually first, if I1 and I2 if I1 is less than or greater than 0 and I2 is also less than or greater than 0, then we traverse through the entire array, so we return true. But if only one of them is reached that value, then we traverse through the entire thing and one of them still has value, so then they cannot be equal. Else if we compare string 1, I1, if string 1 and I1 is not equal to string 2 and I2, that means the index of string 1 is not equal to index of string 2. Then we return false. Lastly, we decrement left and right. Unexpected token while left. While left is greater than 0, right is greater than 0, or right is greater than 0. I say while return index. While left is greater than 0, or right is greater than 0. Unexpected token while. Why? Left is string dot length max 1, right is string while left is greater than 0, or right is greater than 0. Eudemon was a programmer. Yes, I am a programmer. You open YouTube to procrastination from coding and you find coding. Is there any reason you're doing this in JS? I can do it in other languages. I can do it like PHP, I can do it in Python. What else do they have here? C++. I can do maybe Go. But for me, JavaScript is the fastest. C++. I haven't touched C++ and Java since I left school. So these two are out of options. It's just faster in JavaScript. So if you do it in Java, right? Java you have to specify your types. So you're actually doing more typings than if you do it in JavaScript instead. So that's why I chose JavaScript. Unexpected token while. Nande? Unexpected token while. I don't get it. It looks correct to me. Oh, cause I have a comma here. Damn it! Damn, I have a comma here. Yeah, so I'm gonna say this again. Mac, please stop spamming nonsense. And please stop spamming and then also retracting. So it's wrong. Okay, so I1 equal to get value string 1 and then left is right now here. Right, so I1's after I1 enter here, index count is 0 while index is greater than 0. If string at the current index is equal to this, which is not, and if count, which is not, so we go to next else. If count, because this is 0, so this is not, so next, so break, so it index matters. Oh wait, yeah, that's fine, because else we just break it out without doing the same index. So return index will return z. So I1 is index of z. So z is not if z is not less than 0, so this pass. This also passed. And string I1, string I index 1 should be z. Right. And then so now we look at index 2, get valid string 2 right side. Right side is here. So string right side, if string index, the current index is sharp, we do a count plus plus. Because this is else statement, so we after this we do index mass. Wait, we do index mass. Count plus plus. And then while index is greater than, we go there. Else, if count, if there's a count, we do count mass minus. And then we index mass. So now index is here. Index is y. So the next iteration, because this is not sharp and count is 0, so we just break it out. We break it out and return the index. So return should return y here. So now I2 should return index of y. So we are comparing z to y. Should be false. Why is it like that? Oh, left minus. Wait. Left is equal to I1 minus 1. And right is equal to I2 minus 1. I don't think this matters here in this example. Okay, so before returning index, we're gonna console log the index root limit 0, 0, 0. Index at 0. What is it there? After the first iteration of this, it returns 0. What app or what I'm using? I'm using something called Broking the Coding Interview. So this should not return index 0, but it's returning index 0. So left is string dot length minus 1. Get values. Wait, hold on. This? Don't tell me it's this. This? Gonna use this test again. Use example. Stop. Run again. This don't get values non-function. But wait, this is the test case. Oh, because it was different test case. Okay. I'm gonna use this as test case. Use exit. Use as this as test case. Run. Okay, SD is 0, 0. Which it should not be 0. String is array this, index is this, console log, then index this and 0. Wait, 0? It's passing an index of 0. Okay, I see the problem here. Left. Where's the index 0 here? Left is equal to string 1 dot length minus 1. Console log string 1. Oh! It concatenates the entire thing. It concatenates the entire thing into a... So this is an array of 1, array of length of 1, and everything here is stuck together. So splits, if I split using this. Yep, so now it's an array of these. So each character will be its own index. Now it's passed. And submit. Wrong. Return is true. Expect is false. Okay. Here's an example. ABC, ABC. Wait. This runs. Okay, ABC sharp 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 6. ABC sharp sharp 6. That's correct. It returns -1. Oh, sharp 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 -1. That's true. Sharp sharp -1, and then sharp sharp this 3 sharp, so it's 6. Oh, so I1 is -1 because we have 4 sharp, and I2 is also I2 is 0 because we have 3 sharp. But these two should still be the same. Output is true. Expect false. Why is it false? It should be true. It should be true because you ABC, you backspace, backspace, backspace. Now you have nothing. You ABCD, ABCD. Oh. ABCD, backspace, back. So now it's A left. Oh, okay. So this should be false. Oh, this is both of them less than 0. Return true. If both of them are less than 0, return true. True, okay. Now this part is false again. Z. Both of them less than 0. If both are less than 0, that's true. If one of them is... If one of them is less than 0, then it's false. Oh, yes! Okay! Yes, yes! JS shenanigans. Usually if you write something, it's always faster you write it in loose type language than a strong type language like Java or C++. There are rare cases like in rare cases if you write like big giant languages and you use loose types, sometimes it messes up because the value that you're passing can be in any types, and sometimes what you're expecting a value to be in certain type, but it's actually passing in a different type. That's why sometimes it causes problems, unexpected problems. That's why people want to use JavaScript so bad they introduce TypeScript. That's how TypeScript got around. So yeah, weakly typed. Well, people like JavaScript so much they even wanted to use JavaScript so much, so they introduced the TypeScript. But if you're writing for like web applications, I think writing in JavaScript is much faster. Even with strong types, even with like using TypeScript for strong types, I think it's still faster if you're writing for web applications. So you're dependent on your applications. It's faster to write. It's slower to write in strong type, but some people say like it's more secure. It's like it's faster. Like the if you're writing for like low level machine hardwares, it's slow. It's more efficient to write in strong type. There's a power level for type language, yeah. That's why you see a lot of bank companies they use Java. They still stick with Java. Next, this complete. Next. I think I'm done with this. I'm done with this madness. It's only 2 hours of coding, so my brain is starting to cook. Anyways, I'm gonna schedule a master duel. Gonna schedule master duel after this. So I see you guys later. Bye bye. So next one we're gonna start a new pattern. For the next one. Oh, they have hard questions. Damn. What coding challenge? This is a Guru King, the coding interview. Any coding cup. Yeah, I'm gonna schedule Master Duel stream probably in an hour or two. Yeah, bye bye.
人唱歌，关于你梦中的理想国。空间时间交织，连成线融在身边，不知又不觉，眼看不见。难道就真的没有存在过来过？乌兰云眼泪声和闪电，一朵昙花盛开在夜间。到底有点什么都不见，名为真相的幻影毫无意义。所有人质都隔着一层不真实，若能感知胸口的呼吸，就该坚信脚下的